All right, this is review lesson number 2. We're going to be talking all about equations. In our past lesson, we talked all about expressions. Now, an equation is when two expressions are set equal to each other. So remember, each expression is just a mathematical statement. It's just talking about certain values or amounts. Now, an equation is saying those two expressions or those two statements are equivalent to each other. They're equal. So it'll always have an equal sign. If it has an equal sign, it's an equation. If it does not have an equal sign, it's an expression. Now, a proportion is an equation where two fractions are equal to each other, and you can solve it by cross-multiplying. So a proportion is a certain kind of an equation. You just specifically set two fractions equal to each other, and you can always solve those by cross-multiplying. And we'll see what one of those, a few of those will look like. So our first example, we're going to be talking about translating sentences into an equation. Now, remember, equations will have the equal sign. So equation equal, we're going to have an equal sign in whatever we are talking about. Now, the equal sign, so I'm just going to write that out here, is always sets one statement on this side equal to one statement on this side. So expression and expression. So if our full sentence says 5 times x minus 20 is y squared. Now we've got two different statements being talked about here. The equal sign that separates them is this word is. It's saying is equal to, it is the same as. So is like our equals. Now over here we have one statement, y squared, so we could literally just write in y to the power of 2. Now when we say 5 times x minus 20, well, we'd say 5 times x and then minus 20. Now we've got two statements set equal to each other. 5x minus 20 is or equals y to the second power, or y squared. And that's all there is to it. At this point, we won't necessarily solve these, especially because we have two unknowns, and one of them is a squared, so it's the second power. But right now, we're just going to be able to write these out. Example 2 moves things in the other direction. If we need to translate an equation into a verbal sentence. Now, the equation just says 8n cubed equals m plus 1. Now, as a sentence, what this is saying is 8 times this amount, n cubed. Now, again, remember, because of our order of operations, we have to do n cubed first, then we'd be multiplying it by 8. Now, that is all set equal to this unknown value m plus an extra 1. So, putting everything together, we can say 8 times the value n cubed. So first we would do n cubed, then you times it by 8, is equal to the value m plus 1. So 8m cubed equals m plus 1 is 8 times the value n cubed that is set equal to the value m plus 1. Example 3. Now we're looking to actually solve some of our equations. So remember, each equation is just two expressions set equal to each other. Now, in this one, we've got these two expressions. 10a minus 8 is set equal to this expression, 22. Now, an expression can just be one number, like this one, 22. It can be a couple different numbers all put together, 10 times a minus 8. Both of these are statements about the values. So we have two expressions that are set equal to each other. Now to solve this, we're going to have to work backwards in a sense. So I'm going to show you on this side what is actually happening here. Since we want a alone, we're trying to get this value a all by itself. We need to think what is happening to a in this expression. Well, the first thing is it's being multiplied by 10. When you do a times 10, that becomes 10a. That's where this piece came from. Now, what's the next thing happening to a? Well, you're subtracting 8. Again, we just did this by order of operations. Looking at our order of operations, what's happening to a over here? Timesing by 10, then subtracting 8. So your whole expression says this amount, 10a minus 8. This is all one expression. Now, this expression is set equal to 22. That's what we said right here. So to work backwards from 22 to get it to equal a, we just do the opposite of what we did here. So instead of minus 8, we would have to add 8. Because again, that would basically just cancel these two out. When we add 8 to 22, it becomes 30. So 10a equals 30. Now again, to undo this times 10, to get rid of it, we would be dividing by 10. When we do that, those two match up or kind of cancel out. So when we take 30 divided by 10, it becomes 3. So a equals 3. A is the same as 3. Now this is what it looks like when you're doing it to two sides of the equation. Since it was 10a minus 8, we would add 8 to both sides of our equation. And again, minus 8 plus 8 cancel out. So our equation now says 10a equals 30. And we got that part right here. We started with the 10a minus 8 equals 22. That was everything down here. Now it became 10a equals 30. That's this piece right here. To get rid of that 10 out in front, we're going to divide both sides by 10. Divide by 10, divide by 10. Because whatever you do to one side of an equation, you have to do it to the other side. And again, why did we do it? Well, this over here shows us a little better why we did it, because it's the opposite of multiplying by 10. When we do that, this 10 cancels out with this 10, and we're just simply left with a equals 3. And that's how we would solve two-step equations. Got another two-step equation here. Negative 9 equals negative 11 plus r over 6. Now again, this one might be kind of hard to see what we want to do to both sides first. We can see there's a divided by 6, so we might want to multiply both sides by 6. But again, let's think of PEMDAS, or the order of operations. What is happening to r first? Starting from r, looking at this side, this expression, the one with r, we're actually dividing by 6 first. So that makes it r over 6, or r divided by 6. What's the next thing happening to r over 6? Well, it's actually adding on a certain amount. It's adding on negative 11. Now, it might be kind of hard to see why it says why we're adding on a negative 11, but if you think about it, this is where our commutative property comes in handy. If you've got 5 plus 3, it's the exact same thing as 3 plus 5. You can always flip two numbers around as long as they're around this plus sign or addition. So what that means for us is, in this equation, we've got negative 11 plus r over 6. Well, we can take this r over 6 and move it to the front of the plus sign, and the negative 11 move it to the back. So it would be like saying, I'm going to get rid of this actually. It would be r over 6 plus negative 11. Those two mean the same exact thing. So if we add a negative 11, that's where we got our original expression from. Negative 11 plus r over 6. Now, according to our equation, that's all set equal to negative 9. So, to move backwards from negative 9 back up to find what r equals, we just have to do the opposite of each of these. So adding negative 11 would be the opposite of subtracting negative 11. That should be a negative. And remember, when you subtract a negative, it's kind of like saying add. Add 11 to this. So negative 9 add 11 would become a positive 2. And again, remember, this and this essentially are canceling each other out. We're just doing the opposite of those operations. So what this is saying is r over 6 equals, or is the same as, the value 2. How do we undo or get rid of this divided by 6? We would multiply by 6. So 2 multiplied by 6 makes 12. So r equals 12. And again, remember, this and this cancel each other out. So let's see how that looks back on our original equation. What we're doing to both sides is we're adding 11. adding 11, remember, is the same as subtracting negative 11. So we can add 11 to both sides. That'll help us cancel this out, which means right now our equation says 2 equals r over 6. That's the same as right here. R over 6 is the same as 2. Well, we have that right here. Now, to get rid of that divided by 6, we're going to times or multiply by 6 on both sides, which means this and this cancel out, go away. 2 times 6 makes 12. R equals 12. Again, it's the same thing we found over here. You can set these up either way. You can do it this way or this way. This one just kind of helps you see what is happening to our variables, r, x, a, whatever we're using. This way helps you remember to do the same thing on both sides of the equation to get your variable alone. Either way, you always have to follow the order of operations. Example 5, we now have one of those proportions we were talking about. This is a fraction set equal to a fraction. K over 9 equals 10 over 5. Remember proportions, we can always solve by cross multiplying. K times 5, 9 times 10. K times 5 is 5k, 9 times 10 is 90. So we have 5k equals 90. To get rid of this 5 in front of the k, remember this is saying 5 times k. So we would divide by 5 to get rid of it, which means we divide by 5 on this side as well. Those will cancel out, and we're left with k equals 18. So again, once you get your variable alone, you've solved for it. We know that k has to be 18 in this case. Example 6, we need to solve this proportion, this equation. Again, we can always cross multiply proportions. We'll cross multiply x times 5 and 3 times 4. X times 5 is 5x. 3 times 4 is 12. So remember 5x means 5 times x, so we need to divide by that 5 to get rid of it. 5 and 5 will go away. Now we have x alone equals 12 divided by 5. Now 12 divided by 5 is not a whole number. So you can either leave it as 12 fifths, which is totally acceptable, or we can say that 5 goes into 12 2 whole times and leaves 2 fifths left over. Or, I guess I didn't put this on here, we could also leave it as a decimal and call it 2.4. All of these mean the same thing. 12 fifths, 2 and 2 fifths, or 2.4 all mean the exact same number. All of them are acceptable answers. Again, the most important part is you did the work correctly. You cross-multiplied. And last example, example 7. We need to solve this equation. Now this one is not set up as a proportion. We have a fraction, yes, but it's not set equal to a fraction, so we can't cross-multiply. Now, I'm going to show you again on this side what's happening to x to figure out how it would look on the equation. First thing over here, on top of the equation, it's 10 plus x. Remember, our associative property means that's the same as x plus 10. 10 plus x and x plus 10 mean the same exact thing. So the first thing happening to x in the numerator of this fraction is it's adding 10. After you add 10, that's why it's called 10 plus x, which again, remember, means the same as x plus 10. They're the exact same expression, just mixed around. After we have 10 plus x, now if it helps, think of that whole thing in parentheses. It's all one big answer, one big number. What's happening to that whole expression? Well, it's being divided by 4. That's why it's all on top of this bar. It's all being divided by 4, not just one piece. So the whole thing is being divided by 4, which means it now looks like this. 10 plus x all over 4. And according to our equation, that's set equal to 3. So as we work our way backwards, how do we undo divided by 4? Well, we multiply by 4. And we know that 3 multiplied by 4 is 12. Also remember, these cancel each other out. Now, 10 plus x equals 12. How do we undo the last piece to move backwards from 12 to find out what x is? Just do the opposite of this, minus 10. So 12 minus 10, that becomes 2. And again, remember, These two are canceling each other out. That's why we used a minus 10, because it's the exact opposite of plus 10. So x in the end equals 2. Let's see how that would play out using our equation. Again, remember, order of operations tells us what's happening to x first. It's adding 10, then dividing by 4. So to undo that, we would need to multiply both sides by 4. When we do that, this and this part all cancel out. The left side of our equation still says 10 plus x equals 12. 3 times 4 is 12. And again, that's all right here. That was that spot. Now to get x alone, because it's x plus 10, it says 10 plus x, but we can think of it as x plus 10. We can subtract 10. That'll cancel that out, and we subtract 10 from this side of the equation as well. That just leaves us with x on one side being equal to 2. So x equals 2. And that'll be our final answer. And that'll be our last example for the lesson.